This section is on ratios and proportions. When we talk about a ratio, so let's get this out of the way. A ratio is really no different from asking you for the quotient, which is division, and it's a quotient of two quantities. Okay, and there's two ways to express a ratio. You can either express it as A is to B, okay, which I think most of you have seen it. This is actually what you call the colon notation. Okay, and another way to express a ratio is A over B, which is called the fraction notation. So there's two ways to express a ratio. Okay, and if you are not told which way to express it, then the more common choice would be the fraction notation. Okay, so because that is something we are very familiar with since we've done fractions a lot, and we know that we can reduce all fractions. So similarly, you can reduce a colon notation as well. So take for example, if I ask you what is the ratio of, say, 4 times to 3/4. Now, the trick about ratio is they must be of the same unit. Okay, so two quantities of the same unit. So you cannot compare dimes with quarters, for example, because they're not the same thing. But translate what dimes mean. If you recall, dimes is 10 cents, and there are 4 of you, so equivalently in terms of money, it's 40 cents. And quarters is 75 cents, is 25 cents, okay, each, and the 3 of you, so that's 75 cents. So now that they're both in cents, that means they now have the same unit. So the ratio answer to this is if you want 4 times and 3/4, I cannot compare them as 4 and 3 because they're different units. As you can see, the units are different. So this I have to compare it to as 40 cents versus 75 cents. So now that the units are the same, the answer is just going to be 40 over 75. And just like any fractions, you have to reduce this. So if you divide this by 5, top and bottom, the 40 becomes an 8, and the 75 becomes a 15. So the answer to this question is 8 over 15. Okay, so this is what you call a ratio. So take note of that. They must be of the same unit. So you cannot compare them when they are of different units. So that's the trick that you have to take note of. Okay, and once you know what a ratio is, then you would understand what a proportion is. So a proportion is where you have an equality of two ratios. So a proportion is an equality of two ratios. So a proportion would be something like, take for example, 3 out of 6 is the same as 1 over 2, so that is called a proportion. Okay, and in the example we've seen above there, 40 out of 75 is really the same as 8 over 15. So when you have two ratios that's the same, that's called a proportion. So a few ways we can ask you the question. Take for example, we could say, all right, we have 3 over 15. What would it be up there if the bottom here is a, let's say, a 45? So then you would be asking yourself, okay, for these two to be the same, I have to make sure they're equivalent fractions, right? So how do I get 15 to become 45? Oh, I have to times 3, and then I have to times 3 to the top. So there, the answer to this question is 9. Okay, so that's one way to do it. But what if now I were to say, okay, 7 over 5, what is that? Let's say 8, and what should I put up there? Okay, and then that's going to be tricky, because now you're going to sit there thinking 5 times what will give me 8. So this is where we teach you a new method. Let's call this number as x, and we do this technique called cross multiplication. Okay, and what that means is the denominator on the left side will multiply by the numerator on the right side and vice versa. So it becomes 7 times 8 is the same as 5 times x. Okay, and so this is 56 and that's 5x, and if you divide both sides by 5, it will tell you that x should be 56 over 5, which you can stop there, okay, or you can continue and do your division, 56 and 5, so that's a 1, another 1, remainder 1, so it's at 11 and 1/5. So that's why you notice the second example compared to the first one is much harder because the number is not a whole number. It's a actually an improper fraction, or you can look at it as a mixed number. Okay, so a proportion, you can figure out what you need and you multiply by what you need. A lot of times it's not that easy, so we learned cross multiplication. So let me show you another example. This is how we'll ask you, can you solve? Okay, 27 over, say, 2x minus 1 is equals to 9 over 8. So what we've written for you is two ratios, okay, and what do you think you need to put into the x position so that the two fractions will be reduced and come to the same answer? So the quickest way is to cross multiply, so which comes up to be 27 times 8 is 9 times. Now 2x minus 1 has to be crossed over, so you need a parentheses. So take your calculator, so you can, since you can use calculator in this class, right? So multiply 27 times 8. 27 times 8 comes up to be 216. This you need to distribute. So 9 times 2x is 18x. 9 times 1 is 9. So I'm solving for x, so I'm going to add 9 to both sides. 216 plus 9 comes up to be 225 divided by 18x. Okay, and equals 18x. So I'm dividing by 18 on both sides. 225 divided by 18. This actually, I can reduce this, right? I can divide by 9 actually, so this becomes a 2, and 225 divided by 9 comes up to be 25, so x is 25 over 2, but to be more precise is 12 and a half, okay, but if you stop at 25 over 2, I'm okay with that. So improper fractions are fine so long as you reduce it, okay, so make sure you reduce them to the lowest term. But what we are really saying is that if you put the numbers back in there, the two fractions, they are really equivalent fractions. They look the same. So proportions are especially useful in solving problems, and a lot of times we kind of give you a relationship first. So let me show you an example. Let's try this problem. Okay, so a lawn mower. So a lawn mower uses a mixture of gasoline and fuel. Each quart of fuel is mixed with 3 quarts of gasoline. So if the tank holds 8 quarts of the mixture, how many quarts each of fuel and gasoline are required to fill the tank. So what you notice is there are two unknowns here. We're talking about number of quarts So number of quarts of which are the two types? This gasoline, right? So gasoline, and then number of quarts of fuel. So those are the two unknowns that we're talking about, gasoline and fuel. And you are told that for every quart of fuel, you have to mix with 3 quarts of gasoline. So since we don't know how much of each one, which means it means that every quart of fuel, I have to combine with 3 quarts of gasoline. So whatever I use for fuel, gasoline will be 3 times of it. Okay, so the fuel is less, gasoline is more, because every quart of fuel mixes with 3 quarts of gasoline. So whatever is fuel is going to be gasoline is 3 times. Now you are told that the total amount of mixture, so watch out for this. The 8 quarts that you see here is for the entire mixture, meaning it's a combination of gasoline and fuel. So gasoline plus fuel adds up to be 8, right? So the total amount is 8 in total. So that's 4x equals 8 divided by 4 tells you x is 2. So if you translate backwards, it means that you need 2 quarts of fuel. So 2 quarts of fuel, and you need 3 times 2, that's 6 quarts of gasoline. So this is how you would do a proportion problem if you are given the relationship. There's yet another type of problem, which is also proportion problems, that uses a proportion statement to solve. Okay, so let me show you the example. Let's say a taxpayer pays the state tax of $300 on an income of $9,000. If the tax rate remains the same, how much state tax would he have to pay if his income increases by $12,000? Now, there is a bit of trick in this question, but first and foremost, there's 2 unknowns. That's the tax and that's the income. Okay, so what you're given is a relationship that the tax you would pay is $300 if your income was $9,000. So that's a relationship that you know right off. Okay, so what happens is, because the tax rate is kept the same, so the ratio is the same, as in like your tax versus your income, the ratio is the same. Okay, and what you are asked is what would the state tax be? So that means you don't know what it should be, but you know what his new income is. So what I need you to pay attention is you are told his income increased by 12,000. So it doesn't mean that his income is now 12,000. It actually increased by that much. So his new income is really what his old income was, and added another $12,000 to it. So his new income is really 21,000. So remember, it's increased by 12,000 and not increased to 12,000. Okay, so if it's increased to 12,000, then 12,000 is his new income. But in this case, it's increased by, so you have to add the difference. So the 12,000 is the difference. And that's why his new income is $21,000. So you can set it up as a proportion statement, and now you solve this. So we can actually cross multiply and solve this. So let me write this problem on the other side, the equation, and I'll show you how to solve it. So the equation we had was 300 for tax if his income was 9,000, and we do not know what the state tax will be, but we know his income is now 21,000. Okay, so one quick way to do it is to cross multiply, which is what we discussed. So that's cross multiplication, and so that comes out to be 300 times 21,000 is equal to 9,000x. But your job is to find x, so I'm going to divide by 9,000 on both sides. Now this is a class you can use calculator, so go ahead and multiply. But I just wanted to show you that I could do this without using a calculator. And this is how I would do it. I'll cross out the zeros. Oh, that's a 9,000 right there. Okay, so I'll cross out these zeros with those zeros. So that's coming to 21 right there, and the 300. So the 9 and the 21 is the 7 and the 3. I'm dividing by 3. And this reduces to be 100. So straight away I know x is 700. Or in other words, I'm saying that the state tax for an income of $21,000 is $700. Okay, so always get into a habit of writing a statement when you're done, and so that's your answer for the word problem. So you will notice that there is two ways to solve a problem. You can either set it up as a ratio, a proportion, and do cross multiplying, or you could use an unknown like x and apply the relationship to it.